Hi again, Julia. They limited me to a 5-minute video, um, and I used all that up on question number 18. Here's question number 19. We're again going to use something called slope-intercept form of a linear equation. This is just one of several forms that a linear equation can be written in. Any linear equation, you're always going to see a y in it, which is the dependent variable, an x in it, which is the independent variable, and you're usually going to see a number in front of it. Well, you'll see numbers maybe in a lot of different places, as you did in number 18. Number 19 is we're ready to actually just write the answer. As long as you know that slope-intercept form of a line is y equals mx plus b, where the number that is in the place of m represents the slope, and where the number in the place of b represents the y-intercept, we can just go ahead and write the equation. So we're going to write y, oops, if we have a pencil, we're going to do that. We're going to write y equals, and then what do they tell us? They tell us that the slope must be 4/3. So that's going to be the coefficient for x, 4/3 x. And then b is -4. So we can either write that as plus -4, or more commonly and more easily, we'll just write -4. One of the things that's true of the slope-intercept form y equals mx plus b, you'll see some b's that are positive and some b's that are negative. So that plus doesn't really mean that b always has to be a positive number. It just means that it's the number after the linear term. We would, if we wanted to, we could graph this now, because we know that where the y-intercept is and where the slope is. They haven't asked you to do that, so that's a good deal. If they did, you would put the y-intercept. Notice that the y-intercept is, even though it's a point, it's represented just by the number b, whatever b is. What is implied is that the y-intercept is the place where on the graph where the line crosses the y-axis, so the vertical axis, which means that the y-intercept is going to be located, if you write it in the form of a point, which is x comma y, then that point is located at 0 comma b. So 0 for the x, that means it's on the y-axis, and then b, wherever b happens to be. This one is at -4. This has a slope of 4/3, which means it's increasing at a rate slightly faster than 1. It means it goes up 4 every time it goes over to the right 3 units. So if we went up 4 and over 3 from to the right 3 from our y-intercept, we find another point on that line, and as long as we have 2 points, we can connect any 2 points with the straight line. That's what our graph would look like. There are other interesting forms for linear equations. There's something called point-slope form, which is less commonly used, but it's pretty useful form for a linear equation. We have general form, which is what the question number 18 was written in, and required you to do some a little bit of algebraic manipulation in order to get it into slope-intercept form. But slope-intercept form is a super useful form, because we know what the graph is going to look like. We don't need a handy-dandy little graphing calculator or something like that to be able to type it in and graph it. We can just graph it by hand, and frequently algebra teachers will ask you to do that with linear equations. And generally speaking, the easiest way to do that is by putting the equation, if it's not already in there, into slope-intercept form. All right, hope you got something out of these little lessons and responses to your questions, and look forward to working with you if you're interested. Thanks a lot.